What's poppin', what's poppin', what's poppin'? Dogs, Mr. Allen here, and I'll tell you what is poppin'. The binomial theorem and Pascal's triangle both be poppin' in this dope vid here. We're going to use them both to expand 2x plus 3y raised to the 5th. It's a 2-for-1 special. It's going to be dope. All right, now, check this out. Okay, I'm going to be honest with you. My preferred method for expanding this binomial raised to the 5th power would be Pascal's triangle. I'd lay it out, lay those numbers, boom, fill everything in that orderly fashion, right? But I am going to show you guys binomial theorem, and then we're going to talk about when it's appropriate to use that one or advantageous to use that one, right? But if the choice is up to you, I'd be going with Pascal's on this one. But we're going to show you binomial theorem here and how we're going to get these numbers using combinations, okay? So for my first one here, I'm going to have 5 choose 0. That's going to give me 1. Then my next one, I'm going to go to my next combination here, and then I'll fill in the variables after, right? I'm going to have 5 choose 1. Then I'll have 5 choose 2, 5 choose 3. All right, there we go. Next up, my first term raised to the 5th power and then to the 4th, 3rd, so on and so forth. So I'm going to have 2x raised to the 5th power. Then I'm going to have 2x raised to the 4th power. All right. And then the next one here, we have our second term, the 3y. We're going to raise it to the 0 power, then to the 1st, then to the 2nd, so on and so forth. Okay, now, since both this was addition between here, I'm going to be able to have all addition running through this thing. When it's subtraction, that is a different story, but we'll deal with that in another time. All right, all addition in this thing here. Woo! That is crowded, dogs. That is crowded. All right, so now 5 choose 0, that is 1. You can either work that out, by hand or throw it in your calculator or just know what it is, but it is 1, okay? And then I have 2 to the 5th power, that's 32, right? And then I have something to the 0 power, that's just 1. So here's what we're going to have. We're going to have 1 times 32, which is 32x to the 5th power. Boom. There is our first term. All right. Next one. We got 5 choose 1. That's just 5, and that would agree with Pascal's triangle as well. So what I'm going to have here is 5, and then we have 2 to the 4th power. That's 16. Then we have 16 times 3. 16 times 3 is 48. 48 times 5. Oh, boy. Oh, boy. What do we got? What do we got? I'm going to bust this bad boy out so I don't mess it up. I don't want to mess it up, man. 48 times 5. 240. 240. All right. 240. Then we got x to the 4th. We got y to the 1st, but we're not going to write y to the 1st. We're just going to write y, man. We're just going to write y. All right. Next up, we've got 5 choose 2. It's going to be 10. Okay? So we have 10 times, 2 to the 3rd, that's 8. And then 3 squared. 3 squared is 9, right? So 9 times 8, that's 72. 72 times 10 is going to be 720. We can handle that one. We can handle that one. And then we got x to the 3rd. And we have y to the 2nd. Oh, man. Oh, man. All right. Get excited. It's awesome. It's dope. Okay. 5 choose 3. Also 10. Right? And to agree with Pascal's triangle, I'm also kind of cheating there because it's right there. Okay. So we got 10 once again. 2 squared is 4. 3 to the 3rd power, that's 27. 4 times 27, that's 108, right? 4 times 27 is 108. 108 times 10, just going to pop an extra 0. 108. Whoop, pop a 0 on. Boom, diggity, x squared, y to the 3rd. Dang. You got to be careful, dogs. Hopefully, I haven't made any mistakes. As I'm saying, be careful, dogs. All right. 5 choose 4. That's 5, okay? Then we got, let's see here. 2 to the 1st is 2. So 5 times 2, that's 10. I'm gonna keep that in my head. 3 to the 4th, that's 81. 81 times 10 is 810. We have x, we have y to the 4th. We're almost there, folks. We're at the finish line, right? Okay, we have 5 choose 5, that's 1. Doesn't really matter, right? 2 to the 0, 2x to the 0, that's also 1. No big deal. All right, and then lastly, we have 3 to the 5th power. It's like, let's see here, 81 times 3, is that 243? 243? I'm going to check. Oh, all right, 243. So we got 243. We have y to the 5th right there. Oh, my goodness. Hold on. Stay with me, folks. I got to circle this whole thing. Woo! Fully expanded. That is dope. Let's double check some things, though, right? The x is raised to the 5th, then the 4th, 3rd, second, first, it's gone. No y, y to the first, second, third, fourth, fifth, works its way down, works its way up. Dang, that is dope and awesome. All right, so now let's talk about why the binomial theorem might be handy, right? That was kind of a lot here in this line. It would have been a lot easier, in my opinion, to just write 1, 5, 10, 10, 5, 1, right? And then deal with it. So the binomial theorem is going to be helpful if I said, what is the third term for this guy right here in the expansion? What's the third term in that expansion? Well, the third term would be this one right here, right? That's going to be my 1, 2, 3, my third term. Well, how would I figure out that third term? I would know that I'd have 5 choose 2. It's going to be 1 less than the term number right there. Then I'd have my first guy right here. It's going to be 5, 4, 3, right? So then it's going to be 2x raised to the third power. And then I would have the 3y raised to the second power. Okay? So this number, notice that guy is right there, right? This 2 right here is right here. And 5 minus 2 is 3. Okay? We'll talk about more using the binomial theorem to find an individual term in other videos. But that would be one of the key reasons to have binomial theorem in your back pocket, your back mathematical pocket there, if we ask that type of question, right? Or if you ask for one that's way the heck down the line, like raised to the 20th power, I ain't writing out all Pascal's triangle, right? We could have figured this out from Pascal's, but binomial theorem will do the trick too. Woo! Dang, I hope you guys stayed with me that whole time. That was a whole lot. That was a doozy there, but you guys crushed it. You're awesome. I will see you guys later.